So how do we use this integration by parts? I've got this u times dv. Well, let's just dive in. So I see this integral of 5x over e to the 2x. I think I'll just go ahead and rewrite this as the integral of 5x multiplied by e to the negative 2x dx, bringing up that exponent from the denominator up to the numerator. Now hopefully you can see that that is a product. And usually when you have an e to a power, you might let a u substitution equal to that power and see if you have du. And you just don't because of that extra x. So let's look at that as a product, as in u times dv. So how do you know which one is u and which one is dv? Well, sometimes it doesn't matter, but there's a mnemonic that might help you remember or at least help guide you into a better choice. And that mnemonic is I late. I did not make this up. I got this from other students. And so I will stand for inverse trig functions. That's what you look for first. L would be logarithms. A, anything algebraic like x, x squared, 2x, something like that. T stands for any type of trig functions. And E would be your exponential function. Now this mnemonic is, again, a suggestion of what you should let u equal to. So let's go back and look at this problem and go, okay, if I look at 5x multiplied by an e, well, my e is the last on the list, so I think I'm going to let my algebraic expression of 5x, I'm going to let that equal to u. So that means dv, right, not v, but dv is e to the negative 2x dx. It includes that dx. So looking at this formula, I need u, but I also need v. I need v, and I need the derivative of u. So the first thing I like to do is write down u and dv. And then here I need to find du, which means I have to take the derivative, which would be 5 dx. And here to go from v to dv, I actually have to take the integral of both sides. So how do you integrate e to the negative 2x? Well, you should get negative 1/2 e to the negative 2x. Now I know we usually put plus c. Your hands have been probably slapped for not putting plus c, but in this case we're actually not going to be putting a plus c. We'll take care of that at the very end. So I now have this set up, and I'm going to look at this formula saying, okay, I need u times v, so I need to multiply those together. So here's my problem, 5x multiplied by e to the negative 2x. So according to this, it would be u times v, so I'm going to multiply those together, no integrals, just a multiplication. So that's going to be negative 5/2 x e to the negative 2x. Then I need to subtract the integral of v du. Okay, so I have to multiply those together. So I have a minus because of the formula, and then I have a minus because of that v. So I have minus a negative 5/2 e to the negative 2x dx. So just to kind of clean that up, I'm going to take my constant outside. So I'm going to put this as positive 5/2 times the integral of e to the negative 2x. And this is where you hope that this integration by parts has helped you. In that, did we end up with an integral that you know how to integrate? Well, sure, because if you look, we already did it once. So we're just going to do it again. Now, does that always happen? No, but in this particular case, it did. But the good news is that I now have an integral that I know how to integrate. So this is negative 5/2 x e to the negative 2x. And I'm just going to remember this. So I have plus 5/2 because of my constant multiplied by negative 1/2 e to the negative 2x. And now I'm going to put that constant there. And I'm just going to go one more step, putting that together. So that would be minus 5/4 e to the negative 2x plus c. Now at this point you could make it a little bit prettier by factoring some things out, but you know that just sometimes leads to mistake. So there's my answer. So that's a very simple example of using integration by parts. Let's look at another one. Now you're wondering, why do I have those 3 asterisks there? Because I want to emphasize this part. We do not, as of yet, have a rule for the integral of the natural log of x dx. In fact, that's my next problem. So we don't have a rule. So keep in mind when you're choosing u and dv, dv is, I'm going to say never, but about 99% is never, or most of the time, is never going to be your natural log function. That's just not the best course of action. Remember, on our mnemonic I late, L would be the logarithmic function, or the natural log, and that would be what u equals to. Okay, so we have our formula, u times dv equals uv minus the integral of v du. So hopefully you can see that we have x to the 5th multiplied by a logarithm. So if I use that mnemonic, I late, L comes before A. Remember, A is algebraic, which would be x to the 5th, L logarithm. So this time I'm going to let u equal to the natural log of 3x, and so that means everything else is dv. So that would be x to the 5th dx. Please put that on your paper. Right? Now I have u, I need to find the derivative. So this is going to be the derivative of the natural log of something. The something goes on the bottom, and then the derivative of that goes on the top. And then, of course, I'm just going to reduce that to 1 over x dx. On the next part, we're going from dv to v, so we have to integrate. So we're going to use the power rule of integration. So that's going to be x to the 6th over 6. And again, we'll put that plus c at the end. Okay, so we have our problem x to the 5th times the natural log of 3x dx. So that's going to equal to u times v, those two multiplied together. So I have x to the 6th over 6 multiplied by the natural log of 3x. So u times v minus the integral of v du. Okay, so I have x to the 6th over 6 times 1 over x dx. Now remember, the goal is hopefully that is something you know how to integrate. Well, it is if we do some simplification. So I'm going to pull out my 1/6. I'm going to reduce my x's to x to the 5th. And lo and behold, I just have the power rule. So I have x to the 6th over 6 times the natural log of 3x minus, and then I'm going to add 1 and divide by that, so that's going to be this 6, and then when I divide by another 6, that's going to be 36 x to the 6th plus c. So one more time, I started out with something I did not know how to integrate, rewrote it in terms of a different integral that I do know how to integrate. Now, speaking of those asterisks and how do you integrate the natural log of x, that's what we're going to look at next. How do you integrate the natural log of x?